This LOS is Explain a Test Statistic, Type 1 and Type 2 errors, a significance level, and how significance levels are used in hypothesis testing. A test statistic is a quantity calculated based on a sample whose value is the basis for deciding whether or not to reject the null hypothesis. So we'll start with this first example of a test statistic. We have our sample statistic minus the value of the population parameter under the hypothesis divided by the standard error of the sample statistic. So recall from previous LOS, we learned how to calculate the standard error of the sample statistic, and that's the standard deviation divided by the square root of n. Hypothesis testing. So we're going to look at a two-sided hypothesis test here. It's used when testing to see if a population parameter is different from a specified value. So here the hypothesis is the mu, or the mean, equals 0 versus the alternative hypothesis that it does not equal 0. Because it does not equal 0, it's a two-sided hypothesis. We're looking at both sides of the distribution, both sides, the two tails. It's a two-tailed test. So if we're looking at a 95% confidence interval, we would have 2.5% on either side. So the critical statistic, the critical number is a z-score of 1.96. And I'll show in the next slide where we get that. So we're going to calculate our test statistic, and if it's greater than 1.96 or less than negative 1.96, we're going to reject the hypothesis. If it falls in between from negative 1.96 to positive 1.96, we're going to fail to reject the hypothesis. So if the hypothesis population mean is larger than the upper limit of the 95% confidence interval, we reject the null hypothesis at the 5% level. So where did that 1.96 come from on the previous slide? Well, we need to look at the table of the students' t-distribution, one-tailed probabilities, and because again that was saying the 95% probability, but it's a two-sided test, so we have to look in the 0.025 column because there's 2.5% on the left and 2.5% on the right. So here's that 1.96. So you can see at the 99%, we often say it's 2.58. It rounds to 2.58, okay? And at the 90%, we're at the 1.645. So that's where we get our critical values when we're doing this type of hypothesis test. We're getting it from the table of the student's t-distribution, one-tailed probabilities. Let's do a quick little practice problem to check our understanding. An analyst conducts a significance test to determine if the relation between two variables is real or the result of chance. His null hypothesis is that the population correlation coefficient is equal to 0, and his alternative hypothesis is that the population correlation coefficient is different than 0. He gathers the following information. The value of the test statistic is 2.8092. The critical value at the 5% significance level is 1.96. The critical value at the 1% significance level is 2.58. The analyst most likely conducted A, one-tailed test and can reject his null hypothesis, B, a two-tailed test and can reject his null hypothesis, or C, a two-tailed test and cannot reject his null hypothesis. Okay, the correct answer was B. It's a two-tailed test and can reject his null hypothesis. But let's go through the answer fairly slowly and see exactly why. We remember from the question that the alternative hypothesis was the correlation coefficient was different than 0. If it's different than 0, it means it does not equal 0, so it's a two-tailed test. So immediately we can discount A, it's not correct, because we're looking at a two-tailed test. So just remember that sometimes we'll say different than 0 and not equal, instead of saying not equal to 0. Different than 0 is not equal to 0, so it's a two-tailed test. So the second, we need to see, can we reject the null hypothesis or cannot reject his null hypothesis. Sometimes we do see the words here except, so just be careful with that. So we know that the critical values on a two-tailed test for 95% significance level is 1.96. And I showed you just on the previous slide where that 1.96 came from. It came from the student's t-distribution for a one-tailed. So we know that on the 95%, we were looking at the 0.025 column because this is a two-tailed test, okay? So then it gave us, we didn't have to calculate in this case the test statistic. It gave us the test statistic as 2.8. So that's why I like to use my little graphs here. If the test statistic, if you calculate it and it fell between negative 1.96 to 1.96, let's say the test statistic was 1.65, then we would fail to reject. But they gave us the test statistic. It was 2.8092, so that's why I like my little graph. We draw it, we can see it's to the right of the critical value. Because it's to the right of the critical value, we reject his null hypothesis. So B is correct and C is incorrect. So another practice problem to check our understanding. The 95% confidence interval for the sample mean is negative 4.56 to 3.27. The null hypothesis is that the sample mean is equal to 0. The alternative hypothesis is that the sample mean is not equal to 0. It's a two-tailed test. The null hypothesis most appropriately should be A, rejected at a 2.5% level of significance, B, rejected at a 5% level of significance, or C, accepted at a 5% level of significance. So the correct answer is C. The 95% confidence interval contains the value 0, thus the null hypothesis cannot be rejected. So let's just go through it again, and I drew my little graph. So we see the 95% confidence interval for the sample mean is negative 4.56 to 3.27. So I drew that there, negative 4.56 to 3.27, okay? The null hypothesis is that the sample mean is equal to 0, and the alternative is that it is not equal to 0, okay? So we can see I drew here at the 5% level of significance, the critical values would be from negative 1.96 to plus 1.96, and I put in here the green area where we failed to reject the hypothesis. So you can see what it's saying is that the 95% confidence interval contains the value 0. So when you're looking at the hypothesis and the null hypothesis, that it's equal to 0, not equal to 0, that's falling in here. So you fail to reject. The null hypothesis cannot be rejected. So as I said, be careful with the language a little bit. It's saying that it's accepted. Fail to reject. Sometimes they're saying it's accepted at a 5% level of significance. If the test statistic exceeds the critical value or is outside the range of critical values, the researcher rejects the null hypothesis. Critical values are like confidence intervals, okay? So we can have two types of errors. A type 1 error is rejecting the null hypothesis when it's actually true. So I put here a little memorization, RT, rejecting when true. That's one RT, type 1 error, okay? So we reject a true null hypothesis. That's called a type 1 error. Failing to reject when it's false, so I put FF2 as my little memory aid. Failing to reject the null when it's false is a type 2 error. We do not reject a false null hypothesis. This is called a type 2 error. When we reject a false null hypothesis, that's a correct decision. And when we do not reject a true null hypothesis, this is also a correct decision. So don't forget, they like to talk about the two errors, but don't forget what is the two different types of correct decisions, okay? And the significance level is a probability of a type 1 error. So we're going to finish this LOS with a quick little practice problem. To check our understanding, hypothesis test fails to reject a false null hypothesis. This is best described as A, a type 1 error, B, a type 2 error, or C, a test with little power. So the correct answer is B, it's a type 2 error, because the question asks fails to reject when false. So remember, FF was 2, RT was 1, reject when true was 1, FF, failed to reject when false, is 2, type 2 error. And that's the last slide for this LOS. Thank you.